Welcome to the Green Fix Positive Tipping Points special series with guest host Liz Courtney, an award-winning film director and science communicator. This 7-episode weekly special is offering a fresh lens on the climate conversation. We'll explore the science of solutions, the many sparks of change already underway, and the moments when small shifts create big impacts. Enjoy the show!
Welcome to the Green Fix, Positive Tipping Points. I'm Dan Leverington.
And I'm Liz Courtney.
And for this special episode on the Green Fix's Positive Tipping Point series, we're unpacking sea level rise, melting glaciers, warming oceans, and extreme weather events with one of the world's leading climate scientists on the subject, Professor Benjamin Horton, who is Dean and Chair Professor of Earth Science at the School of Energy and Environment, City University of Hong Kong. A leading authority on sea level change, he previously led the Earth Observatory at Singapore and held posts at Rutgers and Penn universities. His work, spanning from Antarctica to Asia, has earned the European Geosciences Union's Plinius Medal, the American Geophysical Union's Voyager Award, as well as the Geological Society of Australia's W. Stores Cole Award. He is also a fellow of both AGU and GSA and advises COP, the IPCC, and governments worldwide.
Thank you so much for joining us today, Ben, for what promises to be a very revealing insight into one of the most existential threats to the world, sea level rise. Just for the listeners, is there a way you could just give everybody a crash course in the mechanics of sea level rise?
Yeah, when you look at climate change, there are actually some elements that we understand really, really well. We have known for decades, maybe over a century now, about, well, what happens if you increase the amount of carbon dioxide, not just generally, but actually quite specifically, the relationship between the concentration of carbon dioxide and the temperature of the Earth. The second confidence that we have is that if you increase temperatures on our planet, you're going to get sea level rise. And we understand the contributors or the mechanisms or the processes that are responsible for that. When you're looking at global average sea level rise, there are two components that drive it. One is the volume of the water. If you warm up ocean temperatures, the water molecules occupy a greater space, water expands and sea level rises. And that process dominated sea level rise for much of the late 19th and most of the 20th century. The second process is a mass problem. So if you increase atmospheric temperatures and ocean temperatures, you melt the land-based ice. And through the hydrological cycle, that goes into the ocean basin. So it's a mass problem. So water in the form of ice goes into liquid, into our oceans, and you get an increase in sea level rise. So volume has dominated our historic period, but present day we're dominated, continued by glaciers, but we've got these two massive ice sheets at our poles, Greenland and Antarctica, and they now contribute 40-50% of the sea level rise that we're experiencing. So that's the global problem. But then what are you interested in? Well, you're interested in regional scale. So how does Australia suffer, or how does Asia suffer? How does Europe suffer? And you have a variety of regional processes that influence sea level. Some of those are related to ocean currents that can push or pile water up on one coastline at the expense of another. Others are related to gravity. So these ice sheets have a colossal gravity, and therefore water is attracted to them. If you reduce the mass of these ice sheets, the gravity reduces and the water quite simply sloshes away. So one of the things that's sometimes quite hard to explain is that the greatest impact of a melting ice sheet at the North or the South Pole is in the equator. Even though they are thousands of kilometers away, they get the greatest impact. It's not the Arctic shorelines close to Greenland, or it's not the tip of South America that is having the greatest impact from Antarctica. It's the Asia-Pacific region. So they're on the regional scale. Then you have to think about local factors, and they're even more complicated to think about. They involve tectonics, they involve groundwater withdrawal, compaction, Unfortunately, most of our large urban areas, again, especially in Asia, are on deltas, and deltas just naturally sink because of all the sediment pressing it down. And then, unfortunately, in these areas, we then withdraw groundwater, which presses it down even further. So, when you're thinking about sea level rise, yes, we can readily understand the global problem, but then it becomes more complicated when you get into the regional one. And then when you get into the local, it becomes even more complicated and in some cases, really, really difficult to project the future.
I love that comment and explanation, and thank you so much. And I just want to pick up on one thing. The question, are we living in unprecedented time or not? And that Antarctica was able to give us the solution and the answer. I just wondered, can you take us back on the Vostok ice core records? Because I would imagine that most listeners have no idea about this ice core record and what it told us about the time that we're living in now.
The Vostok ice core is an amazing set of discoveries by the international community. Indeed, you know, led by, well, it's Vostok, it's led by the Russian Science Foundation, which is quite interesting now because, unfortunately, because of what's gone on in Russia, we don't hear of world-class Russian scientists anymore. But take us back 20 years, they were at the forefront of understanding our polar ice sheets. When you think about climate change, there are many big questions that the population want to know. What's the impact of carbon dioxide increasing? We've done a lot of work on understanding that relationship. We spend a lot of time trying to test the models based upon data from when the first models were developed in 1990, pushing it out to 2025. We do a lot of hindcasts, starting the model and running them back through time. We do a lot of what we call attributions, so run the models with just natural variability from volcanic emissions and sunspot cycles, and then running it just with anthropogenic emissions or running it with just land use changes. But then the other question that someone should always ask is, well, how unusual is this? And that's really difficult. We have been observing carbon dioxide since the Keeling experiment. So Keeling, again, one of these amazing scientists who just thought, right, I want to calculate the amount of carbon dioxide on planet Earth. And so he spent a lot of his early years trying to understand where on the planet would give us our observational records. And then he worked out that high elevations on an extinct volcano in Hawaii, when he collected the carbon dioxide measurements, would give you the carbon dioxide concentrations of planet Earth. And so those experiments started to show that every single year we're increasing. But how do you go back through time? Well, again, amazing scientists understood that in Antarctica, snowfall would produce annual layers of ice. And that if the ice sheet in Antarctica is drilled correctly, you could go back through time. So a little bit like a Tringy ring. Every layer would give you an annual layer of ice. And then within that annual layer of ice are air bubbles. And those air bubbles are within the crystalline structure of a snowflake. And they record the atmosphere of when that snowflake fell. I mean, absolutely amazing. So now you've got the answer. You can go to Antarctica, and if you drill it correctly, you can go back from the start of the Keeling experiments in the 50s, and you can go back to the 1900s. You can go through the last millennia. You can go back, published right now, goes back 800,000 years into the Earth's history. So what we found out is that over the last 800,000 years, that the amount of carbon dioxide waxed and waned between around 180 parts per million by volume and 280 parts per million by volume. So whenever the Earth's climate was warm, the amount of carbon dioxide was high at 280. Whenever we had an ice age, the amount of carbon dioxide was low at 180. So we found out for the last 800,000 years, year after year, decade after decade, century after century, that when carbon dioxide increased, the temperature of our planet increased. And when carbon dioxide decreased, the temperature of our planet decreased. An amazing finding. The second thing we discovered was that the rate of warming and the rate of increase of carbon dioxide was always more rapid than the rate of decrease, indicating that the Earth will warm up faster than it will cool down. Living in unprecedented times. Our current carbon dioxide concentration is 425 parts per million by volume. We have not seen that in the ice core records. Nowhere close. We peak out at 280. So that's the huge concern, that we're now 140 parts per million by volume greater than the geological record in the ice cores. But it doesn't stop there. We don't have the resolution, but there are other archives on planet Earth that do give you a picture of carbon dioxide. The last time on planet Earth that the amount of carbon dioxide was comparable to today was 2.8 million years ago. And 2.8 million years ago, we had high concentrations of carbon dioxide. That was the result of the Earth's plate tectonics breaking up the Earth, having incredibly expansive volcanoes, spewing huge amounts of carbon dioxide into the atmosphere. 2.8 million years ago. And this is where, when we think about climate, we have observations, we have theoretical understanding, we have predictions from process-based models, we have empirical forward interpretations, but we also have information from the geological past. So 2.8 million years ago, you've got higher concentrations of carbon dioxide than today, but it's not much higher, 450, 500. Where was temperature? Temperature was 3 to 5 degrees C warmer than today. So exactly where we're heading on a high emission future. And where was sea level? Sea level was 10 to 20 meters higher than today. And that's because Greenland and Antarctica had shattered. So when we think about climate change, I know what the Earth is capable of in the past. So I know that if you increase the amount of carbon dioxide, temperatures will go up 3 to 5 degrees C. Greenland and Antarctica shatter. Sea levels are at least 10 meters higher than today. And then I know that civilization collapses.
It's really powerful. Thank you, Ben. It's an amazing image, really, from the source to the end point. If you're thinking from a policy perspective, what are 3 actions that you would ask or demand policymakers to take in the next 5 years to impact the rising sea levels that you're already seeing predicted?
Well, I suppose 3 things. Invest in the science. Without the science, we're blind. What we're concerned about now is tipping points, planetary boundaries. So we need to invest in the science to monitor them. It's very hard to monitor these tipping points. So when we're crossing these boundaries, we need to be far more accurate. And therefore, if we're going to solve it, we need to make sure we know that we're recovering and that we're doing the right thing. So we need to desperately keep on investing in the science. And that can be global, that could be regional, that can be real micro local scale. So, understanding urban heat islands in a community in Kowloon of Hong Kong. It can be looking at flooding from a tropical cyclone in Clearwater Bay in Hong Kong, or it can be looking at the Antarctic ice sheet from satellite-based missions. The second thing is that we need to, at all costs, avoid the problem. I mean, seriously, we need to invest in renewables. We cannot rely on technologies that are unfounded. Carbon capture and storage, for example. Carbon capture and storage theoretically is a solution, but right now it's not. So we desperately need to invest in renewable energies and start to bend the curve on carbon dioxide emissions. And we don't have much time. One of the advantages of climate change is we still have time. So you're talking to me and there's hope and we can solve this problem. But you talk to me in 5 years' time and our carbon dioxide is still going up, we're done. We're done. We will not be able to bend the curve. We'll have crossed that threshold, because another problem with carbon dioxide is it stays in our atmosphere for hundreds to thousands of years. So you've got to peak our emissions by 2030. The Paris Agreement was one of the most amazing pieces of science, where the whole scientific community came up with the threshold of 1.5, but then they also came up with the solution, or the pathway, and the pathway was peak emissions by 2030. And we have to do that. So it's like tick tock on this. We're in 2025, got 4.5 years left. So that's the second one. We have to avoid the problem. And then the third one, which is one we've sort of dramatically failed in, is community engagement. If I was asking a policymaker, you'd go, policymaker, right, okay, you need to invest significant proportion of your gross domestic product into science, a significant proportion of policy regulations on reducing our emissions. And then the final thing is, and that obviously plays into this podcast, is community engagement. We've got to communicate our science in a way that people understand that it's in their best interest and that solutions are really good. We need the community to all come together on this. Young and old, rich and poor, all together. So 3 things.
Fantastic. Thank you. And building on that, what makes you optimistic that we can prepare for and mitigate sea level rise?
I mean, the world is an amazing place. And we're in a better time than we ever have been in terms of, life expectancy, in terms of our connectedness through social media. So that's my general framework. But then I'm also very fortunate that I work in education. The best day of the year in the whole of my career, whether I've been in the UK, the US, Singapore, or Hong Kong, is the first day of term. Because it doesn't matter whether it's a Hong Kong, Singaporean, an American, or a Brit. The first day, you just see all these young people wandering in, their eyes wide open, and they're so excited, and they're full of hope, and they've got their dreams. That's what gives you hope. And that hasn't changed in my 30 years of my career. And I hope it never will. And then the other thing is that hope is the technology is just quite simply amazing. What we're able to do. So, like the final good news story. And I'll give you 2 in actual fact. So one's mine and one's somebody else's. So with climate change and tropical cyclones, since that's a topic of the month right now, tropical cyclones or typhoons get their strength from ocean heat. And you warm, stick carbon dioxide in the atmosphere warms up, oceans warm up, but they're not going to warm up equally. And the amount that they warm up today is not going to be the same as tomorrow or the same as they were 10 years ago. So what we observed in a publication we wrote last year was that there was an increasing warm pool offshore of Vietnam. Okay, so we wrote this paper. It was a combination of Singaporean scientists, American scientists. It was led by a young female academic. So we wrote the paper, came out in a big journal. But one of the advantages that I've had, and that's through working with Liz and working with others, is that we know the importance of communication. So we worked with Nanyang Technological University, who I was employed with, to do a press release. And that press release was delivered very appropriately about this changing risk to the coastline of Vietnam, because one of the warm pools of water that we had observed is offshore of Vietnam. So we communicated that, and NTU did a good enough job that there were Vietnamese media involved. They ran a story on that. They then ran a story on that got picked up by policymakers in Vietnam. And then they wanted to know what to do. And then the discussion was about having better understanding of the problem and evacuation routes. What happened earlier this summer? A huge typhoon made landfall in Vietnam. What did the government do? They evacuated millions of people out of harm's way, saving thousands of lives. We wouldn't have been able to do that 10 years ago. We didn't have the technology. The second good news story. In my school, I have a professor, Professor Edwin Sam. He and his graduate student wanted to try and address the topic of cooling technologies. They wanted to develop the material that would reflect the most amount of sunlight that it is possible to reflect. How do you do that? How do you think about that? Student goes, well, I was looking around on planet Earth at, animals who survive high heat. Oh, okay. And he said, right, so there's this ant. And I'm going like, what? There's this ant that lives in the Sahara and it's able to withstand, daily temperatures of 50 degrees C and nightly temperatures of close to freezing. And he mimicked the skin of this ant, particularly its 3D structure. And so he was able to develop material that would then reflect over 90% of the incoming solar radiation. And that's a theoretical game changer. It was published in Science. But he didn't stop there. Edwin and his student they could do it on a micro scale. Then how do you implement that at a macro scale? Because that's part of the translation aspect. So they were then given some money by the university to start a startup company, and then they tried to think about how can I do this sustainably. So they wanted to look at local building or local materials, commonly waste products, that could form the base of this material, and then they can use the 3D structure. Edwin now has a company that is worth, well, I think they have orders of 20 million US dollars per year because of this technology. And then the real feel-good story of this is, where does he apply it? Well, his first study is to cool a building in China for orphan children. That's what he wanted to apply his technology, not to some big tech company or some data center for Microsoft. No, I want to enable orphan children to be in a better living and educational environment. And I was just like, you stop there. So there you go.
Amazing.
People like that on it. It's amazing.
It really is. It's like, built on the back of an ant.
Yeah. Yeah. Oh, and there's other things he does with it. Then he went, right, well, you're going to have buildings that you need to keep warm at night and cold in the day. So you need to have material that's like a chameleon. So then look to the genetic properties that allow chameleons to change their color. So now this material that they place on buildings can change their color.
Wow.
And what does he do now? He has painting materials. He's working with EV because they're very interested in painting the surface of the cars, because then that means the cars don't need as much heating or as much cooling. What does that do? Stretches your battery length. The big problem with EVs. Bingo.
So, second to last question. We have developed what we call the Green Fix Magic Wand that we like to give to all of our guests, that you have the ability to use to enact change between now and 2035. How would you like to use that magic wand?
Do you remember when one of these, you've asked me this before, Liz, do you remember you asked, what would I want? And I said something like, and it's a bit late now, I said I wanted Taylor Swift to marry a climate scientist. That's gone now. She's gone and got engaged.
Sorry about that one.
And I don't mean me, because I'm happily married, okay? But I'm just saying that it's this aspect that, what do we need? We need behavioral change. Backstory to this is that when I was in Singapore had the warmest temperature since records had begun. I mean, it was blistering, like shattered all records, okay? I'm asked by Channel News Asia to come onto TV. Come down to the studio, okay, I'm going to talk about this historic moment. I'm down at the studio and they say, well, your story's you're not going on air, okay? And I'm like, oh my God, what's happened? What's happened? So, I could get my phone out. what's happening. Yeah, because Ukraine, well, it's been going on for so long, but I was worried, oh my God, there's been a problem with the nuclear power plant. I couldn't find anything in the Guardian, Washington Post, New York Times. So then the producer walks past and I said, like, well, what's the problem? And he said, all the Taylor Swift tickets have been sold out. And I was like, what? You're bumping this story for that? He said, yeah, but that's what the readers want to know. And I was going like, okay, I've wandered off, very depressed with society, da 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 da. But then I thought, no, what we need to do is change the balance. So if I had the magic wand, there are two things I'd want. One is to get social media stars to be energized on this problem. Some are, but I want them all to be like this because I think that they have a responsibility. I have a responsibility. I think the media has a responsibility. I think policymakers have a responsibility. And I think people who are influencers have a responsibility. So I wish that. And the second thing is that I wish climate scientists were at the very top table on this, and they're not. We know that the advisors to governments on climate change are never climate scientists. They're commonly economists, and that's not right. Al Gore we can think of as an incredible proponent of climate, but his knowledge of climate is rather limited. And I don't mean that as an insult. I mean, he's done great things. No, Greta Thunberg, amazing, has a huge voice on it. She's not doing a PhD on climate. In Singapore, Avi Menon, incredibly smart, nice man, but he's not a climate scientist. In the UK, David Miliband is in charge of the environment. He's not a climate scientist. None of them have taken an undergraduate degree or a PhD. And that's what needs to change. You need someone who's dedicated their life to this problem and has got the qualifications, and they're advising the governments. And they're advising the big businesses. I've given talks to banks and, they say, oh, why are you here? And I said, well, I want a seat on your board. And they'll go, and I go like, no, I'm being deadly serious. Put me on your board. No one does, and that's what needs to happen.
Well, I think I want to speak on behalf of all of us, Dan and Loretta and myself, the gratitude we have for the time you have just given us today, and also given the listeners the opportunity to understand through your very excellent way of explaining complex science in a very digestible and easy way to understand the mechanisms of sea level rise. We really understand the time that we're living in is really of great urgency and acceleration. We're so grateful that you have given us a little bit of hope. It's so awesome on so many levels for the people that are listening today, for the world that we are trying to create for the future, and for young people that are thinking of being scientists in the future to know that there is hope and there are amazing people coming up with tremendous ideas and designs.
So you've asked me a lot of things, so I'm going to ask of you, and I'm going to ask of your listeners. You need to support us. And I don't mean in a dollar value. I mean, we need your support. I mean, I think that social media can bring us together and it can divide us. You see a post by a climate scientist or scientist in general, like it, support us, especially the young people, especially people who are commonly from marginalized or minority communities. Their voice has to be heard and it has to be supported. Remember what we're trying to do here. We're trying to save planet Earth. It's a big thing. Oh, and I'm going to say something else. And the final thing, just to finish, is a big thank you, because you're who we need. We'll continue doing our science, but we need you to amplify our message. And so it's a big thank you for you. You're doing it because you believe in our message. So I'm really grateful for that, because otherwise I will just continue to talk to a mirror, of other scientists. I'm always very, very grateful to the media who step up and want to communicate this.
I agree with you, and I really want to, any media that are listening to this also, It's time to step up. We all have to step up, and where we can in communications, whether it's in social media or streaming with news and scientific information, we have to do it and we have to step up. And that's across the board, all different streamers globally
Hmm. Hmm.
have to do
Well
it.
said.
Yeah.
Yeah. Right.
Excellent. Thank you, Ben.